In this video, we're going to look at another example of using chain rule to help us find implicit differentiation, or derivatives using implicit differentiation. So this one we have the equation x squared minus y squared plus z squared minus 2z equals 4. And we want to find the partial of z with respect to x and the partial of z with respect to y if we think of z as an implicit function of x and y. Now again, I like to think about it just moving the equation, everything, and set it equal to 0. Now since I have a constant on the right-hand side, it really doesn't matter because when you differentiate a constant, you get 0. But just to keep myself consistent, I like to just move everything to one side and imagine a 0 on the other side. So I'll subtract that 4 over, and I'm going to let my capital F function be x squared minus y squared plus z squared minus 2z minus 4. Then we can, from the chain rule, we can calculate our partials with respect to x and with respect to y, much like what we did in the previous example when we did dy dx. So I'll get negative the partial of f with respect to x over the partial of f with respect to z. With respect to x, differentiate the first term, I get a 2x. There are no more x's. So literally the derivative with respect to x is just 2x in that case. Differentiate with respect to z, I get a 2z here and a minus 2 here. There are no other z's. So I get a 2z minus 2 on bottom. So I get, and then if I cancel the 2's everywhere, I get a negative of x over z minus 1 for my partial of z with respect to x. Likewise, when we do the partial with respect to y, we'll do the partial of f with respect to y on top, partial with respect to z on bottom. We already know that the partial with respect to z is 2z minus 2. That didn't change, so that's still on the bottom. Looking for the top, the only term that has a y in it is the second one. Its derivative is negative 2y. So if we simplify everything, we'll get a y over z minus 1 for our partial with respect to y.